time no see. Yes, it's been so long.
Good. Are you hear me?
Yeah. Yes. Can you hear us?
Yes, I can hear you.
Okay.
Yes, it's a long time ago. I was in Vietnam. It was nice to meet you.
Yeah, nice to meet you too. I'd like to introduce you, Mr. Tuấn, who is in charge in the new recycling bin. You see him?
Yeah.
Because last time they didn't met him. Okay. So today we would like to have a meeting with you to discuss about the 4 main points. The first one is we discussed about the current situation of new recycling bin followed to the design brief.
Yes.
The next point is as Gerhard already sent us some new technology and new manufacturing methods. For example, screw, another shipmental screw, we call that, and another manufacturing process. And the next point is the design team also have a meeting and find one other solution, and would like to hear your comment.
Yes. And the solution about the recycling bin.
Yeah, right.
Yes.
Yeah.
Okay.
And the final point is should we continue with the sample based on the 3D drawing or not, or what is the next step? We would like to discuss with you directly to get the confirmation as soon as immediately or maybe later, but if much faster if we have no meeting and we have to wait each other for a long time.
Yes, it's a fast solution. That's why you get feedback now.
Yes.
So it's better for you and for me.
Okay.
Okay, then you will start with point 1.
Yes. I would like to open and share you the screen and open the meeting report that we have sent you before already.
It's for me also okay. I have your laptop with this meeting report, so you can share if you want, but it's not necessary for me.
Okay. Okay, for the previous meeting, we have already discussed with the design team, production team, and QC team, and we found some advantages and disadvantages about the current design. The first one is the frame and structure seem very strong, but by the way, we also have a question: how strong a structure or frame should be? Do you have any idea or any specific requirement to show us? Because we want to test how strong a frame should be. So we want to hear some more detail of strong structure frame.
Yeah.
Yeah, this is the first question.
Yes, I understand you. But first, I didn't see you. I see you only in a small project. Can you share me your room so I can see you better?
Okay. Better now?
No. No, I can see me.
I think I don't need to share screen.
Stop sharing.
Okay, I think you have a
now yes, it's okay. Now I can see you. Good. Yes, I understand your problem. In past quiz for you in the current recycling bin, we tested already this feeling. So we now I'm not sure what is the correct way, because when we define only a force, so I'm not sure is that enough, or is it also feeling? So yeah, send me, or is it in the only? So in the report, I think one point from here, he will define a force and the maximum deforming.
Yes.
Is it right? Yes. And so I'm not sure how we can define it correctly, so that the recycling bin is not too wobbly, but it's also not good if it's too stable and too heavy. So this is the reason why we need a sample to test it.
Yes, I understand.
But I would say it's not easy to define the correct force. So we can define it, but it's not. I'm not sure is it the correct force and the correct deforming. So here send me the example 100 Newton from the right side, and the maximum deforming is, I think, 5 millimeters. So, but I can't say is it good or not.
Can I have a comment?
Yes.
Yeah. Last time I have already requested the angle digital equipment, right?
Okay.
Yeah. We can use the current recycling bin and put on the side of the wall. We check if we set up, for example, 0 degree, and after that we do like the meter gear has put on the frame. We try to press and see how different angle.
Yes, this is a good idea, because the last version of recycling bin, I think it's stable enough. So this is a good reference.
Yeah.
So this is better than we define any force and any angle or any deforming measurement. So it's better we will take the current version.
Yeah.
And you will you can test it, deforming, or change the force or whatever, and then you will get more feeling for recycling it, for a new one. How we can test it.
And after that, we got the result. We have a force gauge, we have a angle measuring, so it's easy to test by fixed 4 feet and try to test somehow to check the deformation. And after that, we will have a result. And based on result, we can decide that we need to reduce the deformation around, for example, 70% or 50%. And after that, we will have the specific number easy to test with the next sample.
Yes, we can do it. So that's a good idea. Take the reference from the current version. But maybe if it's not stable enough, later we can increase or decrease the force or the deforming measurement. But for basic, is it good? We will take the measurements from the past version or previous version.
Okay, can I go to the next one?
Yes.
Yeah. We design the 3D drawing based on our manufacturing process. So
Yes.
most of component is we can make ourselves. No need the special tool. No need it's quite simple to make in our factory. It's just only there are many components only, but almost them are easy. So that is the reason lead to some part which is need to be strong. We have to use the high thickness. For example, we have to choose 1.5 instead of 1, or maybe 1 mm instead of 0.6 or 0.7. So it's quite easy to make with our situation.
Yes. Okay, I understand. You will change the thickness of some material, some parts.
I mean, it's the current design is easy to make by our factory. This
Right.
is the one advantage, but also have a disadvantage because it take more weight and maybe structure will not very stable.
Yeah. Yes. I think it's okay for me to change the thickness of materials. Is not a problem. Huh? But then we have to change the design, because then we will make the frame like punching and bending only one part. So it's not easy to have the same thickness of the. The problem is you have the same thickness of the completely part. So then we need another design, right?
It's quite simple meaning. I mean, it's all of the part which we use for design is easy to make by our company without special tool.
Yeah.
Yeah, just meaning like this. Nothing else.
Right.
Yeah.
But you have other solutions, right? Later, have better solutions.
Yeah, if we apply to the new manufacturing process or new manufacturing method, we can choose the thickness thinner. But at that time, we have to do special tooling to make the, for example, the beading or the rift like this.
Yeah, yes. But I know, Pierre told me, if we change the material, the thickness of material, then we need another tool. Is it right, Pierre?
Yeah.
For the new manufacturing method of screwing, if we change the thickness of material, so we need another tool. So this is very expensive. If we need maybe 5, 6, or 10 tools for one product, I'm not sure is it the right way. Maybe we can the tool later for another product. This is okay, but please remember that. Or
Yeah.
when you decide the thickness of material, remember that we need always another tool for when thickness of material is changing. And you understand?
Yeah, I understand.
Right. Yes. Okay. If we change thickness of screwing method, so we need another tool. So maybe it's better we need not a lot of tools and not a lot of different thickness of material.
It may depend on the quantity you want to produce.
Yeah, I think we should evaluation it first. If you want to change the thickness of the frames, right? It's too soon to say something about it is not good or is good enough. We need to evaluation it first. If with this part we make many in the future, maybe 1,000 sets or maybe 10,000 sets, it will cover all the fees, all the cost we invest on the tool before.
Yeah, right. Yes, I think best we go every point step by step, and later you can show me your new design, and then we can decide what we will do for the next step, because we have 10 or much more points.
Okay.
So you understand what I mean?
Yeah, yes.
Yes.
Okay.
Prevent me all problems and all disadvantages. You call it disadvantages. So and then we will look what we can do for next step and for new design if we need it.
Okay.
Right?
Yes. Okay. The next point is we always check the requirement from design brief, and we try to make it follow to the design brief.
Right.
Okay. Now I talking about the several disadvantages. If I count the number of hexagon rivet nut on the product and the screw, we need a lot of. So you know, every corner we have to use currently 4 screws and 5, and because we want to assemble, we want to have a smart frame, and they can put left and right, and put the drawer module on the left and the right. There's no problem. That leads to we have to make the frame symmetric. So it means left and right side we need the double screw compared to the one what we need. Next one is we also have a question here. So how many screws should we use for each corner? For example, maybe because we didn't test, we didn't know it. Maybe 2 is enough, or 3 is enough, or is there any other solution to reduce the number of screws, but still keep the whole thing strong? Okay, let's go on with the assembly process. When we check, we have many components, many screws, and that leads to difficult for assembly guide. You know, on the bottom of the side work plate, for example, the left and the right side work plate, we have 4 side screw. Even we have on the bottom with 3 screw. It means that the customer needs to rotate maybe bottom to top, rotate it to assembly on the bottom, and after that it rotate again. So that is not good.
Yeah, this is not good because you need a lot of time.
Yeah.
But it's good for us. It's not our time.
Okay.
So this is right. How many screws we need? 300 is right.
No, 360 is hexagon rivet nut only, but the screw we use the least a half only.
Yeah.
What do you mean when you say only?
Yes, it's a good question. How many screws we need for each corner? So I think we can reduce it, but maybe we have to instead of screws we need a mold for both parts. So we can take the force not over the screw. But at the moment, wie heißt es, wenn man den Wortschluss macht?
In English?
Ja, jetzt in English.
Gute Frage.
You also know it. So at the moment. Yes, you can instead of screws you can make a special shape for each corner. Both parts
special connection.
Yeah, special connection, yes.
Yeah.
So it's kind of screws. You know, with a punching tool. Because it's not good if you need 160 screws and also 320 rivet nuts. So I think we need a better solution for the corner part. So just this not so many screws, but you can work with the new manufacturing methods like special shapes or whatever. So Gerhard looked in the internet for some solutions, right, Gerhard?
Yeah, he said with all of us before.
Yeah.
Okay.
So we can, and then this is not only for corner parts. So you can connect every cover
part.
this made.
Yeah. Okay, and we got to meet.
Yeah,
I got to meet.
yes. I remember the mail from I think last week. So it is the new manufacturing method. So there I show you one or two pictures from Gerhard. You find it on the internet or whatever. So there you can see it. You remember?
Yes, I remember. I know what you mean.
So work with special shapes.
Yeah, right.
Okay? And we need screws, but not so many. And then you can do this also with the cover parts. For every part, which we will connect.
Okay.
Okay?
Okay. The next one is as a production have one comment about the link not strong enough, but that thing should be easy to fix it. So we can go on with next point. Yeah. Currently we are using machinery screw, and at that time that lead to we need the rivet. So the question is, should we try with another type of screw that we call that is a strip metal screw. You know, we have already sent you for how to say
New screw.
Yeah, and new yeah.
No, you mean not hexagonal. You mean the now we will take hexagonal screw inside hexagonal. Right?
Sorry, can you repeat again?
Your question is if we can
Change.
new screws, right?
The question is, can we try with another screw that we call sheet metal screw?
Yes.
Yeah.
Yeah. And the other screw is not like hexagonal head. It's a
toss.
What in English?
The toss. Okay. I can share you the picture and you can see it.
Yes.
Torch or star, different names.
Different names. But there is not a new one in the picture of your report, right?
Yes. You see that kind of screw?
Yes, right. I think this is a good idea because Gira told us this is an international school, so it's not like inch or whatever or metric. So I think it's better for us.
Okay.
So you can test it. Maybe I will talk with PM about that, but I think this is a good solution.
Okay. Okay. There are three backward plate which is made by the flat plate, so it seems not stable enough. So we need to improve somehow. So that is the small thing.
Okay, and how do you solve this problem? Also with another shape or?
I think we can, the bidding solution, or we try to add if I look into the design, I saw the bidding is the best, is the suitable way to make that frame more stable. But it's not for my design. It's not really good idea, because better if we bend for it, the whole thing will be more stable. And you know what I mean?
Yeah, I understand the problem, but I don't understand the solution.
Okay, I can draw on the picture and you can see. So you see the thing I draw here?
No, I can see the report.
Computer. I use the word, but it's not. It's not here. Okay. So let me draw by hand.
Okay.
Okay.
Disappear.
For example, you see here we have only one corner, only one edge have a bending line.
Yes.
The rest of we don't have it. But in order to make that more stable, we can do like embossing. You know embossing.
Yes.
I don't see the line here, but yeah. For example, we
So,
yeah.
and for 5 minutes we talk about the corner part. So I mean there I didn't find the correct word. So I mean also embossing for the corner parts, right?
Yeah.
Understand?
Yes.
Okay. Good. Yeah. Okay. I understand you. You will make an embossing area.
Yeah.
So same like in the
Washing machine, refrigerators, and the back wall.
Maybe before that.
Understand? Yes. It's okay.
But I don't know the how about it? Yeah,
Right.
right.
I have a question, and also for the production team.
Yes.
If you have a big sheet of metal like the back wall, is it possible to embossing them with our machines?
Some machines.
We can do only by some bending tools. We don't have an embossing machine. Yeah?
Okay, yeah.
But
Okay, we will do it on the bending machine.
If you make it over cross, for example, they call it a diamond shape. That will prevent wobbling of the whole thing.
Okay, but if we need small embossing areas like for screws or whatever, then we will do it with the CNC punching machine, right?
As long as we get a tool, yes.
Yes.
Okay, and the big one, we will do it with this bending machine.
In the moment, we have no other choice.
Okay. So for your question, for the design team, for me it's okay to make an embossing part for the backbone plate. So because it's backside and the design is not so important. okay for me.
Yes.
But for the other parts, left and right and in front, so we have to talk with designer if we will make the old for imposing parts. As for you, but I think you will only make the backbone plate with embossing, right?
Yes.
Okay, that's okay. You can try it, and I think it's also good for future because I said you made last weeks about the new manufacturing methods, and we need it in every product. So we can start also we can also start with embossing by the recycling bin. It was okay for me.
Okay. The next point is currently the back balloon is quite heavy. If we just use only steel, we believe after packing the weight will be higher than 28 kilograms. So we would like to suggest you to change several components to aluminum.
Sure, this is not easy because aluminum. If you steel and aluminum, the difference is aluminum is
Lighter.
Much lighter, but it's also not so stable. So if you take aluminium and make it increase the thickness, so it's the same weight like steel, and it's not so easy for welding and and I'm also not sure if it's possible to implement the new screwing method. So I'm not sure. I think we have to talk with Gerhard, or Gerhard had to talk with some supplier of these tools and screws. But I think this is a little bit a problem to screw the aluminium parts with the new method. I'm not sure. So this is a situation. But which part do you want to change?
Yes. I would like to apply to the first part is backward plate, because the backward plate is quite easy to make and without any welding, so that can be made and not effective to the frame, so that can be used aluminum on the back side.
Okay, and what do you think? How thick? Or what is the thickness of this aluminium plate?
Maximum is 1 mm.
1 millimeter.
Yeah.
Okay.
Or maybe we choose the same thick with the steel 0.7. Even
0.7.
Yes.
Okay. Yeah. So I'm not sure is it good, because I think it's better we have the same material for the completely recycling bin. But maybe we can try it. But first, I have to request: is it possible to make the product lighter or reduce the weight with the new manufacturing methods? So maybe we have 23, 24 kilograms.
If you calculate the rivet nut as 5 gram, 4 gram, you cannot save more than 1.5 kilo.
What do you say, one or 2 kilos?
If you save all the rivet nuts, and one rivet nut is about 4 gram, you cannot save more than 1.5 kilogram for the whole product.
Yeah.
So only by replacing the screws, you cannot save 10 kilo.
Yeah, I understand you, Gerhard,
It's limited.
But it's not heavy. It's lighter, right?
It's a bit lighter, but maybe not enough.
So, my opinion is, if we can make the product lighter with the new, or reduce the weight with the new production methods, then I think it's better we will make all parts of steel. But if it's not possible to reduce the weight, then we have to decide maybe to change the material of aluminium. But first, I think it's not good. It's not good because aluminium big plate. There's a big shape of aluminium. I think it's also not stable.
I have another idea.
Yes.
You see the frame on the screen?
Yes.
All of the part here made by the 1.5 millimeter. But I think we can reduce to 1.2. So that can save. Because that frame quite strong. Sorry, quite heavy. If we can reduce the main weight here, we can reduce a lot. For example, the frame here we need around 7.8, 7.6 kilogram. If we can reduce to 5, would be great. Of course, when we reduce the thickness, we need to do somehow to make the frame still keep the stable enough. For example, apply to the new manufacturing method. I think.
So now we came back to the first point of the report about how we can define how stable the recycling bin or the frame have to be. So maybe we should test it.
Yes.
Produce a frame. One time is 1.2 millimeter thickness, and one time is 1.5, and then make a test. How is it different about you can define any force, maybe 100 Newton from the side and from top and whatever, and then you can measure the deforming, and then we can decide what we have to do. But it's not easy to decide it only with the feeling.
Yeah.
You know what I mean?
Yes. I think we can.
One moment, please. You can change the thickness of the frame. This is okay for me. But then we have to test. Then we have to make a test and look how stable it is, and also make a test with the current recycling bin, and then we can look how is it different. Is it same or is it better or whatever.
Yeah, I agree. So even we can change the thickness of this frame until 1 mm because we bend first we nearly bend for nearly same the tooth with the U shape with 25 and 25. So we even can test with 1 mm also. I think to see the difference between 1.2 and 1.5.
But what is the thickness now of this frame? 1.5, right?
Yes.
Yes. Okay. 1 millimeter is. I'm not sure. You can test 3 different thickness.
Yes.
It's okay, but please consider the frame. Not only the frame is is stable. So because when you put the back wall on the frame, so you have more stable.
Yeah,
But
right.
you know.
I mean,
So,
I got.
Yes, please consider that. Not only the frame, also the back wall increase the force of yes. If you put the back wall plate in the frame, so it's more stable when you put the force from the side.
Yes, yes. Because it keeps the whole thing rectangular.
Yes, right. So please consider that.
So, do you think we should compare with it with the first version of the recycling box? At least all of us know about the first version of the recycling box, and maybe we should compare it.
Oh, Grant, do you talk now?
Yeah.
Yes, the problem is I don't understand you. So can you come a little bit front? Because it's acoustic.
Can you hear me now? Huh? Can you hear me now?
Yes.
Yeah, I talking about all of us know about the first versions of the recycling box, right? The original versions. And we never test something like how strong the first version is. So maybe we should test with the first version also to compare, to make sure it's more stronger or something like that, right?
Right, yeah, yes. I agree.
We should base on the first version,
Yeah.
get some tests done we can reproduce, and take them over to the new version. Then we can, in future, we have some values, then we know what we are talking about.
Yes, agree.
In the moment, we have only a feeling of the first version. So we have to convert that. We have to convert that in values. We can read in future.
Yes. And yes, this is I talked in the beginning. But at the moment, we have only feeling of the current recycling bin. But in future, we will define it better and will make it better. So we have to define forces and maybe other parameters how we can find if it's good or not, if it's stable enough or not. So this is very important for you to design the frame and the covers and whatever. So yes, and I think it's a good idea to take the current version to make tests. So we have many parameters like force, deforming in any direction, and then we can say, okay, this is good, and this is the basic for the new one. So I can agree with you, this progress.
Okay.
Right.
Do
Yes.
we have one? Or we have to produce one?
No, I don't have any in stock.
We have to produce one.
We have to produce more.
Yeah.
Some many things, right? Based
I
on this, we
have
can
one point.
already decide about how many school, how many what
Yes.
I think the best is you will make a test. Do you have an old one?
We're going to do
No, we don't have. We need to make one.
we have no one in stock.
Define. We
Okay,
can make it fast.
You load all the recycling bins in the container and send it to Austria.
Yeah.
Austria, yeah, okay. So maybe you have to produce one or maybe two or three, because maybe one is damaged later or whatever after testing. So we need minimum 2 pieces of the current version for testing. And I think the best is the design team define test conditions
Okay.
for the current recycling bin, and maybe Gerhard can support you, because Gerhard have many good ideas about that.
Yeah, he always support us. Huh?
Technical advisor,
He
expert.
can support you. I hope so. Gerhard is okay for you.
Yeah.
Yeah.
Maybe I will pay you a fee next time. Okay.
I always trouble him.
Okay, I will pay you all. The complete design team and production team, I will pay a fee, okay? So, just for motivation. Okay, and if you have a testing condition, please send it to me.
Yeah.
Then we can talk about that, and you can start with the test of the current recycling.
Okay, by the way, the several thing on the bottom is we try to record and hear the new comment, new manufacturing method from Gerhard. For example, we change to sheet metal screw, and to connect the corner. There are many ways, not only bracket with the 4 screw. So it means we can find another way. For example, we mount behind something. So the design team will work with Gerhard to find a good solution.
Yes.
And we design team would have a comment. We always want to go parallel between testing process with the design process for example, we make the small thing and we test to make sure the small thing good. So after that we know that solution is good, and we come back with the good idea. So it means design and testing always would like to go parallel. You know what I mean?
Yes, I know what you mean, yes.
And test as much as possible.
I think most of the or every new technology, it's not easy to implement in a new product.
Yes.
But what we can do is we can also make samples, small samples to test how it works, or how it like to create it. So maybe it's you have to do it parallel. That's right.
Yeah. Okay, there is one comment from Gerhard. So, for example, when we use sheet metal screw, when we assemble, if we didn't fasten the screw strong enough, it means we will just try to mount. So it means two parts cannot fit together, cannot be the same surface, flat. So we can try to make some circle embossing to fit the part and the opposite part on the right position. I think that's why Gerhard can explain you easier than me.
Right. So you can see it in every industrial product, the same thing. There's also the same. What I mean at the beginning, you can make embossing in both parts and opposite parts. So it's good for stable and good for position.
Yeah.
So this is a good idea. But one more thing. We have the design of this part. The design from external designer is very high. It's very try to do that only in backside, maybe on the side parts it's also okay, and parts you didn't see it, it's you can see, it's also okay, but please do it not on front parts.
Yeah, we always respect the appearance design, concept design from external guy.
Because it look like a car. Do you see any screw outside the car?
Yeah,
No.
right. Yes.
Right. So yes, and you know the European people like to have a very clean design.
Yeah, right.
So this is it's not only function. It's more than function. It's also very optical. The European people like to have a very clean design and whatever. So they don't want to see any screws. So please try to make the screws visible.
Yeah. We apply it inside only, and we cannot see the outside.
Inside is good. Outside we have to look okay.
Yeah.
So maybe on the back wall it's okay. It's bottom also okay. On the side parts, so not many screws. Not many. Better is not, but if you don't find another solution, so you can do it.
Okay, got.
But I think it's a good technology.
Yeah.
To connect parts very stable and good position, and maybe with not a lot of screws. So I think it's good. Please try it.
Okay.
Yep.
Yeah, the next, the final point, I would like to say we can improve some small things to make the product better and stronger. So as we have already discussed before.
Yeah.
And now I would like to discuss a bit about the new concept. It's not new concept, new solution from design. I will share you the screen. I have already sent you the step file, but I don't know you have time to check or not. I'm still open here to explain you a bit.
Yes, you can show me. We will discuss the new solution.
Yeah.
Right?
Yes. Okay, we still follow the appearance from external, from concept design, but we based on the requirement from stable with structure and frame. So we would like to create a draft drawing to show the frame. So now I will hide all of the cover part. Just keep the frame only. Yeah, the machine, the computer, and the meeting room not very strong, so it takes time to.
Why you want? It's not booked. Why you want?
So yeah, here you can see the frame. The orange part is almost made by the bending part with the L shape or this shape, and we connect them by somehow. For example, we still can use the segmental screw instead of we use the machinist screw. I just show you the frame. And here the.
But you took open profile, right?
Yeah.
Can you add profile, one profile?
Okay. Yeah. For example, this frame made by L profile, and we weld the connection edge, and after that we put on the bottom bottom cover.
Yeah, but Tom, do you think is that stable enough? This frame?
And we need to test. I'm not sure that will reach the requirement, but it's an easier solution. Yeah, you see here, for example, I took the sidewall plate. You see here the orange, the green part can made by steel or even aluminum. This means that we still can combine both material, aluminum with steel. We can reduce a lot of weight. Of course, the aluminum part is very easy to make. Don't need very special tool or special welding process. It's just maybe bent, and that's enough to connect both components. For example, orange with the green, we can do the rivet. We use some rivet to connect them after powder coat.
Okay, but I can see a lot of screws. So you don't use the screws, the number of screws.
And yeah, the screw you see here is just for showing only. But the number of screws is much less than compared to the previous version. And I guess if I finish the design, I would like to use around maximum 60 screw only, compared to current one is around 50. Yeah, screw is nothing. It's just for I would like to show the frame and how to connect it component only. And if we looking back to the frame, we have just only one both side were frame and two back side were frame. 1, 2, 3, 4, 5, 6, and 7, 8 group part only, including the door, including everything to assembly the back module.
Okay, but can you show me the corner of this frame? One corner.
The corner, yeah. I have a screw here. I have screw here, and I also have a screw on the bottom. This means I screw 3 components with 3 screws. You see here?
Yeah. Okay.
Here. And, I do believe with 3 screws here, and the back side were fixed by very strong frame, so that can lead to the frame cannot be triangle, cannot be, how to say,
Yeah.
Yes.
I understand you, Tom.
Yeah.
So maybe we can test this frame.
Yeah, I would like to test that frame.
you would like to test this crane, okay? And then what we do, it is not stable enough. You pay here for the whole company, or what?
Sorry? Huh?
Yes.
So, okay. So this is your frame, right? So if it's not stable enough, this frame. So what we do then? And what do you do then? You must pay here for the whole company, right?
Okay.
OT.
OT. Beer. Okay.
Yes, I'm kidding you. I think I'm not sure if it's stable enough because we have open profiles. When corner part, so it looks good, but I'm also not sure if it's stable enough. But we can test this frame to look how good it is.
Yeah.
And if the frame good, then we will take this one. Okay?
Yeah.
But the other question is, so with this kind of frame and material, we have the problem with the two materials, steel and aluminium, and I'm sure PM is not. PM said to me for many weeks he will make a completely recycling bin with one material, so it's easy to handle that or whatever. So, but if it's a good solution, we can take this. I think the best is we will make one sample test how stable it is.
Yeah. I'm just talking about the possibility to combine both materials. We still can use only one material, for example, steel. I mean, just we can combine and it's easy. It's not complicated way to combine.
Okay, but this frame, how is the thickness? 1 millimeter or?
I still keep 1.5 as the design brief version.
Okay, yes. Design brief is 1.5 or what?
1.5.
Okay, and you will test this frame also with 1.5?
Yes.
Okay, and if it finishes, you designed nearly finished, how heavy is it? So just a moment, please. Das klingt über die. Ja, ich bin gerade was. Leider. Ja, okay. Ja. Mhm. Ja, genau, also das gute Verfahren, was super alles möglich für diese, ne? Mhm. Ja, von mir aus können wir das schon mal, ich muss es, also, wir werden mit der Vietnamese, kurz mit Drogen. Von mir aus kann man schon machen, ich muss das gucken, dass Buchstaben das Grund ist, aber man schiebt rausschauen, wenn es nicht ist, schon dann ein paar Schieber in und die kann man das dann nicht schon sehen. Ja, genau, wir trainieren immer fertig, Mann fertig. Wenn er, ja, also das Grenzchen links oben, das ist fertig, ne? Dort müssen wir halt immer, was das Plan ist, immer regulieren von 6 cm auf den Kunden. Die können nicht mehr erklären, das ist noch am besten. Very good business. Alles machen sie so, wie die gesagt haben, die Hörer erzählt, online und die ist nicht umgekommen. Gut, muss man sagen, alles okay. Okay. So, Tom,
Yeah.
now you know the weight of your
I didn't check because the I would like to say it's the same.
Okay, maybe
We
you
skip
can
it.
send the weight later
Yeah.
in Skype. It's also okay for me. So, yes, I think we can test it. I told you before, and you can send me the weight of this solution in Skype. It's also okay for me.
Okay.
Okay, and thanks for showing me your idea. Did you pass this solution also with design team and Gerhard and production team and whatever?
Oh yes, I did already. First thing I discussed with the design team and Gerhard, and after that I booked a meeting to discuss with the production team and all of the design and QC and other department already.
Yeah. I think the biggest challenge of the recycling bin and for this solution is to how stable it is. So I think nobody in your room and nobody in Austria can decide or can say just only with some 3D models how stable it is.
Right.
And I think it's really good that we have this meeting because after this meeting we have to start this product test of the current version to define how stable it is. And after we know that, so we can decide if this frame or is the other frame stable enough.
Yes.
So I think this is the challenge to find it and then create a new frame how is stable enough and it's and also the problem is the weight, the connection parts and whatever. So I think this is a big challenge and if we now it's the middle of October. So in for 2 or 3 months, Chris told me, so now Magnus, we need a new product in September. So you have just this. That's not for us. Yes, but I agree with you. We need better specification of stable and frame and whatever. So let's start with the product test. Kwan, what do you think? How long do you need to create two of the current recycling bins without powder coating?
It depends on when we can receive the materials. Maybe tomorrow we can receive the material. I think we should have 2 or 3 days if we need.
Okay. Yeah.
It's not long.
Okay. So next week you can start with this test, right?
Yes.
Yeah.
Okay. Good.
And anyway, this should be designed how to test it first, right?
Okay.
Okay. And another question of this recycling bin you show us for the new technologies like the screwing connection and the embossing and whatever. Possible to implement also in this kind of recycling bin?
Yes. Yes.
Okay.
I have a question. We have planning to test with the sheet metal screw, but production team confirm it. It takes time to order the tooling. So
sorry, I didn't understand. I don't understand you. Which tooling?
You see that kind of screw on the screen?
Yeah.
If we want to test with that kind of screw, we have to order the tooling, punching tool to make the hole. But it will take time, around maybe 20 days.
Yes, right. I remember
are in the process, but we need to have the screw first, and they will make the tool according to the screw. So,
Yeah, that's right.
so that will need all in all at least another month.
Okay.
So I think we should make the samples with the rivet nuts,
Yeah, right. We'll do the one.
and later if we get a tool, we will make the same sample again,
Yeah.
and we can compare. Really, is this screw as strong as the rivet nuts? We know another thing.
So me, I think,
Not wait for this screw, then we lose another month.
Yes.
I agree.
This is also my question. Yeah.
Yeah, so now I think it's not important for us. If the stable, if the frame is stable enough, is not a question of rivet nuts or this new kind of connection, because I think one of the requirements for the new connection, screw connection part, is it has to be the same. It must be the same stability as the rivet nut. So I say almost the same. So we can test now the recycling with the concept, and to test also if it's stable enough or not. So we can need rivet nut for this test, I think.
Okay.
What is your opinion?
I agree with testing the frame with rivet nut first, and after that we will apply the new screw later.
Yes.
Yeah.
But one important thing is, but for the current design, we have to implement the embossing parts, you know, and to reduce the number of screws. Because if we take the nuts, 300 rivet nuts, it's not the same as we will take the new technology only 60 screws. You know what I mean? We will just change the screw, the old the rivet nuts. We will change to the new method, but the new manufacturing processes like embossing and screwing, we have to implement in the currently design. You know, the old embossing parts you showed me before. You understand me or not?
Not.
So I will explain you again.
Yeah.
Before we will start this testing the currently design,
Okay.
we have to implement the all embossing parts we talked before, back, wall, and whatever.
Yeah.
Yes, and also update the new corner parts without many screws. They take also we talk about new shapes and embossing also the
Bracket.
the
The corner.
Yes, yeah, because this we have to implement in the currently designed before testing. Not only the screws.
Yeah. I have one idea to reduce the main thing we have a lot of screw like this because we want to use very smart frame that can be put on any position. For example, left and right and the mid frame. Can we use separate frame? For example, we note that frame on the left, and that frame on the right, and that frame on the middle. So we can reduce a half of rivet nut. Just the manual instruction. So customer that frame on the left, and that frame on the right, and that frame on the mid. Because we have a totally 4 frame. If we are use only one side, so it means we reduce a lot of rivet nut or screw? I can
Yeah.
show you the design.
I know what you mean. You mean the drawer box? We will put it only on left or on right side, but not both.
Yes.
Yeah.
Then it is not modular.
Yes, this is the problem. That one of the requirements from PM is that we will make a modular system. So a customer can decide if he put the drawer box on left or on right side, or maybe he will take two drawer boxes, left and right side, and whatever. And if we change this to only one side, then it's not modular, and the complete system doesn't make sense. You know.
Yeah.
So this is one of the main requirements, that it is a modular system.
But we are talking about two things. We're having rivet nuts and we're having screws.
Yes.
So the rivet nut is 364, and
Yes.
for the back module, you need 103 screws to tighten. Is this right, Tom?
Yeah.
And for the drawer module, you need another 90. Why we need 90 for the drawer module to tighten? We have to reduce this amount,
Right.
not the modular thing. Later that will be no rivet nut, that will be only a punching hole.
But still need 100.
We should come away from 100 screws for the back part. That should be lesser.
Besser. Gut. Yeah, that's right.
Even you push it to the customer, he will buy maybe one, but not a second one.
So,
Think about yourself. If you would buy that product, would you like it?
I would like to. This is
How many screws? How many screws was the old rubbish bin?
Around 47.
So now we are on double.
It's really better. So,
More than one double.
I think every screw we don't need is better for customer and also for us.
You look IKEA. IKEA do that with 20 or something.
20 is. I think 20. You can also look at IKEA. For you, IKEA is also a big company how produce desks and was heißt Möbel.
Furniture.
They also produce the metal furniture.
Well, IKEA is a big company how produce furniture, everything, beds, desks, and everything you need. And they have also a concept which customer have to assembly the furniture by themselves.
Yeah.
So and I do this many times because they buy a lot of this furniture from IKEA, and most of this furniture parts have also 50 to 100 screws, 100 parts. So I think it's okay if you need 60 screws, maybe 70 is also okay, but not more. But 20 screws, I think, I'm not sure if it's possible. If you do it, please. But I think this is impossible. Make a modular system also power box this bag full and take only 20 screws. I think this is not possible. But please reduce the number of screws. This is better.
80 or 70 is okay.
Less as possible.
It's okay. I think, but if you have a good idea, so and you need only 20 screws, well, then I will pay you 2 years.
But then it doesn't have a frame.
Very good. I need 1.5 screw.
It's not hot.
Can I talk something?
Yeah.
I think it depends on the results of the testing.
Over 1 hour.
For example, right? We need to decide how strong the product should be. For example, now the put 4 screws in one corner, but after testing we find out maybe 2 screws is enough. So it's also the way to decrease the number of the screws. So I think the main point now is we had testing first, and based on that we can do many things. Define more easy. How many screws? What about the thickness?
Yes.
Yep.
I think the test is the most important thing to decide how many screws we need and also how stable it is. Because there's not, how many screws we have at the moment in one corner? 10 or more?
4.
I say 6.
Yeah, okay, 4. Yeah.
But that will be enough.
Good. But what is the other screw on the left side? This screw? On the corner? Is it for cover or what?
This one for firstly close the frame and to connect both left and right module.
Ah, okay. Yeah, I understand.
Cột thì dẫn lên cho một lại lên rồi không chứ mà chỉ là lên nó cực lắm. Chứ thân nhỏ gì đâu, nhớ không?
Đúng rồi, cái cảm giác.
Đúng rồi. Cái cột này thì cần cho vài lên để đắp tường đấy đúng lắm.
I'll tell you some, this is for connection, yeah? The drawer module.
Yeah.
Okay, right.
So now including the cover on the bottom, that part will have more than 6 screws.
Yeah. 8.
Maybe more, right?
Yeah.
4 con thôi.
We should try to
Đây
reduce
con này
it.
thôi, con này đây ạ. Cái con 4 con bên này nữa. 4 con bên góc này nữa.
Đúng không?
Cái góc này thì nhiều hơn, góc này thì nhiều hơn.
Mười mấy. More than 10.
How many kilo screws do we have?
Okay, let's open. No con này.
Yeah, it doesn't matter now.
Yes, I think please try to reduce the number of screws. This is important. Yes.
Okay.
Yes. You can see also the bottom part. You have in each corner 2 screws, and maybe in the middle next one. So I think there is no work for every screw. I think you can reduce the number of screws very easy. Some screws and other screws are not so easy. But maybe you took show me the bottom part. You took 10 screws minimum. Well, not just. Yeah, what is that?
2 này, 1, 2, 4 này, 6 này, 8 này, 10 này.
Okay, you have 10 screws. No more.
18 con. 18.
Only.
8.
Only.
Okay. But I think 18 screws is very hard.
Cái con này bỏ đi này, con này bỏ đi.
You can see that you can reduce a lot of screws very easy. I think it's not possible. It's not you don't need 6
can reduce.
Left and right and one in the middle is okay. And on each corner there are
Only four, right? But the other is a shape connection, something like this.
enough.
Yeah.
We still maybe keep some rivet nuts on some important places, because the rivet nut will be more strong for sure. But we want to reduce the complete number of them.
Yes, right, yeah, I agree. I think it's good to choose an intelligent position of where we rivet nut.
But that time you have more than one type screw. For example, is it for example when you put on the assembly kit, assembly accessory, you have to put one is the top key and another one is the maybe Allen key, or we choose the same key but a different type of thread.
Two key.
You mean a different size of Allen key?
Maybe. You know, we have planning to use
why we should keep one key? Then?
6
We
metal
can
screw,
give them two keys.
and we use the top key.
Yes.
If we want to use rivet nut, so it means you have to use the machine screw.
Yes, right. Yeah.
We need to choose one type of key only, one key only. You know?
I don't understand your question. If we need rivet nuts, so we have Allen key, and if we need the new screw, then we have another Allen key. But this, I think it's another name of Allen key.
Some kind of key.
Yeah.
Yeah. Yes. And what your question? You have to more than one Allen key, or what is the question, Tom? I don't understand.
My question is, should we combine both
Both
screw and rivet nuts with the screw with the same key?
You want to use only one
Okay.
key.
One key.
Yeah, is it possible? Do you have screws with metric machine? A
Yeah.
machine screw? With the new head? Is it possible to
The new head was invented 1967. It's not a new head.
Yes.
That is more
Okay.
old than most people here.
This kind of screw.
I know what you mean, Tom. I think it's better if you take almost the same Allen key.
Yeah.
But I'm not sure if this new kind of screw Torx in Austria, we say Torx for the Allen key. It's in Austria Torx.
Yeah.
For this kind of screw.
You can get machine screws with that also.
Yes, okay. And I think you will do that because it's easier to assembly. Otherwise, the customer have to take two different tools, and this is not so easy and not so fast to assembly. You know that. Please take the same tool for every screw if possible.
Yes.
We have to research.
Right. But for all, okay, please Tom, show me the new screw. So, and normally in Austria and also sure in the US, for the machine screw, normal machine screw current version, so we talk the tool Allen key, right?
Yes.
Yes. And for this kind of screw, we will take the word of Torx.
Right.
Okay?
Yes.
So it's easy for us to communicate. Okay, this is Torx, and the other kind of screw is
Allen.
and it's better we will take for every screw the same torques.
How about the TV mount?
TV mount?
Yeah.
What?
I mean the I mean is the for the TV mount order we also use a lot of Allen key screw. Do you have any further
Yes.
planning?
But this is a completely other situation. The mount, the customer don't have to assemble it. They will take the mount and put it on the wall, right? So you have to take some screws. I agree with you, but for the recycling bin, this is completely the customer have to completely assemble it, completely, not only one or two things. So this is the difference.
Okay.
And, you know what I mean?
Yes, I know what.
Then you have to assemble a mixing, and you have to take 5 or 6 different torque screws. This is not good. This is not good for customers. So it's better for us. We will take 1 torque, maybe 2 torques, but not more.
Okay. Maximum 2.
I mean, this screw is similar to M5. So the chance that the M5 for the rivet nut is the same torque is very high.
Okay. Yes. Maximum of 2. If we need 3 different torques, so please let me know so we can discuss about that problem. But better is to reduce the number of different torques.
Okay.
For the situation of mounts, this is a completely other situation because mount is for professional customer, not only for home user. This is one different. That the other different is that you have only to assemble the mount on the wall, and there you have different walls. One is of wood, one is of stone. So this is a completely other different situation. And on the recycling bin, the customer had to assemble the complete recycling bin. So I think.
Yes. Okay, I understand. So that's all. So I would like to combine. I would like to summarize everything that we have already discussed in the meeting. Okay.
Yes.
Yeah. The first thing we will make 2 samples to have a more testing result that we can apply to the new sample. Yeah.
You mean the current version?
Yes. We have to produce 2 samples to test how strong of the current recycling bin, and after that we know the reason, we know the evaluation, we know the reason, we have a result, and we base on the result to implement the new sample, apply to the new sample. Of course, we need to send you the result, the testing result, and how we test and the result to you. And the next point is we will try improve the current design based on the design brief to make this screw and use several new manufacturing method to apply to the current design to make it smarter, stronger, and lighter. For example, we reduce the number of screws, we make the backward plate stronger, and we still keep currently temporary with the screw as rivet nut because we need to make sample and test it first and after that later, if the sample is good, we will have planning to change it to the seed middle school, right?
Okay.
Okay.
Right.
And by the way, we also make one more testing with the new design, new solution. I will send you the weight and send you more information. And we also can think about to make one other sample to test based on the testing requirement created by design team and approved by you.
Okay, yes.
Yeah.
Good. I think the best, you know what we talk the last 2 hours, but you can start now with everything we talk, but I will send you also one email with the most important things of a short report with the important points what we will do as next steps.
Should be better.
Yes.
For members, right?
Yeah.
You agree? And if any misunderstanding or whatever, some people don't understand something, so you can ask me in Skype or you can also call me so we can discuss again. And I think the best is for us, we will make more and more video calls.
That is the thing I want to say now. That's right. Yeah.
So every day or what?
No, not every day.
Yeah, morning 8
Every
o'clock
week
here,
is
huh?
okay.
Every week is good. I think the best is we will make sure fix. You know what sure fix is? Sure fix mean maybe every Tuesday on 8 o'clock or whatever. So every week. So maybe we can find a good time for all of us. I'm not sure. Is this time good? Tuesday morning, Tuesday after. What is the time for you?